Okay, by this point hopefully we've got a good understanding of what's going on. We've checked where things are moving, which directions the forces are in, all that makes sense. So now it's time to put some maths in. Yay! So we're going to come up now with a mathematical model of what's going on. Now in general, for the motion of a point mass, if the force is changing in direction or speed all the time, then the only way you can solve this is by doing it numerically on a computer. And we will do that later in this course. It's very easy to come up with a situation where the motion is so complicated that you just can't solve it with equations. In fact, most motion is like this. However, there are 4 simple situations which are so simple and so straightforward that you can actually write down the equations and solve them. They almost never occur in the real world, but because they're simple, we'll often take a real complicated situation and approximate it to one of these 4 simple situations. What are these 4 situations? Well, one is constant speed. This is pretty straightforward. If you're going 100 kilometers an hour, how far will you be 3 hours from now? That sort of thing. Something we do all the time when we're driving across the outback. The second situation is constant acceleration. It could be constant acceleration in one direction, s equals ut plus half at squared, or it could be projectile motion with constant acceleration in another direction. This is something you should be very familiar with from school. The third situation is motion in a circle. If something's moving in a circle, there must be a force always at right angles to the motion to keep it in the circle, a centripetal force. Once again, this is something you should be familiar with from school. And finally, there's oscillation motion, so-called simple harmonic motion. If we suspended this from the end of a spring, it might bounce up and down, or on the end of a pendulum. These are the 4 situations which are simple enough that we can write down equations for them. As I said, they're usually too simple. No real motion will ever be precisely like all these things, but often it's a good approximation and it helps get some understanding. You should be familiar with most of these from school. The spring motion we'll do later in this course, if you're not already familiar with it. And beneath this video, you will see all the equations for these different models. So basically, either solve a problem by computer, which we'll do later in the course, or approximate as one of these 4 simple models. Constant speed, constant acceleration, motion in a circle, or oscillation.